So let's start just with some catch up on things that are going on in Calico land. So 3.15 has been out for a while. I think we've done one patch release on that so far, and we're probably going to do another one in the near future. We don't have an exact date for that yet. I know a few things have gone into the 3.15 release branch, so some base image changes for a couple images just to remove some unnecessary packages, and we're planning on doing a little bit of work to fix an issue that occurs when node IPs change. For example, if you've got DHCP handing out addresses to your nodes. Calico won't spot that today without a restart. So keep an eye out for that. Like I said, don't know an exact date for that yet, but soon. And then the next minor release is Calico 3.16. That's got a bunch of stuff in it. We're expecting that imminently, probably the latter half of next week. So I think we've got a few people on here who have been busy on some features there, so I'm going to hand it over to Song to talk a little bit about what he's been working on for 3.16. Song, you want to just give us a quick summary of the Windows work?
Sorry, I lost you a little bit. I haven't heard anything from you for last minute, I think. Windows update, yeah, kind of we are working kind of in full gear, like to deliver Calico Windows support for the upcoming Calico 3.16 release. Basically, it provides the Kubernetes overlay networking for Windows Node and also allow user to enforce networking policy for Windows pod. So very excited that we can deliver that for 3.16.
Yeah, very cool. And I think, Song, you've got a demo for us a little bit later to show us what that's all about. Sean, you want to go next and talk a little bit about what you've been up to?
Yeah, so we've been beating on our eBPF data plane, doing lots of robustness testing and that kind of stuff, with a plan to market GA in the 3.16 release. Yeah, busy making fixes and generally like boosting up the robustness of that feature. Also going to be working on the docs to help people get it working later on this week.
Cool, thanks, Sean. Couple other things that are going into 3.16. So we've added support for BGP community string advertisement to the Calico API. So you can attach community strings to different prefixes in your network. And for our users on AWS, Calico now can configure source destination checks on your nodes for you. So this is useful in some environments where that's either not set by default or you don't have the ability to set that on your like auto scaling group, because it can be kind of a pain, for example, on EKS to do that. So there'll be a new Felix config option that lets you configure how you want Calico to manage that. As always, there's a whole bunch of other contributions, bug fixes, minor improvements, and so forth that have gone in over the last cycle as well. I think that is it for 3.16. Looks like we've got Nathan here. Do you want to give us an update on Calico VPP?
Yeah, sure. So on our side, latest release was, the last release was 0.6. We rebased it on 3.15, so we should be pretty much up to date with the latest before 3.16 gets out. On the small changes we did, we added a customized script for deployment and did some work on a CI environment with both Vagrant and bare metal deployments. Maybe some plan to do Elixir in the future to start testing end-to-end the behavior, that we stick to the same behavior as the vanilla Calico. We made the adaptive mode default so that we don't eat all 100% CPU with VPP, because by default VPP starts busy looping, and we came to working configuration where it moves to polling only if it has enough packets to justify that. On the feature side of things, we added support for NAT outgoing v4 and v6, and we started testing dual stack. So for now we support dual stack without NAT 6.4 and 4.6. So only v4 in parallel of v6, and the translation should come in the coming weeks. Kubernetes does not seem to be really definitive about how things work, so I'm not quite sure how things should be implemented, and if we should test all the configurations, but we will see. And so I think, if I'm counting correctly, the last features we're missing, which is quite a big one, is policies for having quite to the full Calico features coverage. So we'll do in the maybe next week 0.7 release with support for NAT outgoing and dual stack, and we'll keep policies for 0.8 hopefully by the mid-September. That's pretty much it on my side.
Pretty much it. Thanks, Nathan. As always, you guys continue to impress with the throughput of the stuff you're doing. That's awesome. Eric, was there anything you wanted to say about what we're doing on the operator side?
Sure. Most of our work right now, we're focusing on migration, and that being from migrating from like a open source manifest install to an operator install. So like what we're working on is reading what the config would be in an already installed manifest install. So, you know, looking at the daemon sets and config maps and whatnot, and translating that into an operator installation. So yeah, so we're the majority of this work is going on in a tech preview. I think it's tech preview migrate install branch is where it's going right now. We're not sure yet when it will get into a real release of the operator. We're kind of, you know, it's a lot. There's a lot going into that, so we're not sure when we're gonna merge over and get a real release, but hopefully it won't be too long. I mean, if you want to, you can test it out. Don't file us too many bugs or anything, because like we said, it's still in progress. But yeah, I think that's all.
Well, file all the bugs you would like, but some of them may be expected at this point.
Sure, I guess so. If you do, make sure you please mention in the bug that you are testing that branch and this isn't on master or some release.
Yeah, and I think the other thing I'd call out in the operator is that kind of related to that, we're adding additional networking modes and platform support there. So I think we did EKS support recently for both Amazon VPC, CNI, and Calico networking. I think that's it. Any other kind of updates or sneak peeks that I may have forgotten somebody wanted to call out? So this week I am unprepared with any hot issues myself, but if anybody has something on their mind, we can talk about it.
So I can mention one that's kind of a Calico hero shout out as well. So Yousong Zhou, I'm not sure if I'm pronouncing his name right, hit an issue where when the API server was like rolling updated or something like that, it took Calico Node a very long time to spot that. And the thing that made the bug report worthy of the shout out was they got all the way down to the like the nitty gritty and figured out exactly what was wrong and why we'd hit this case. So we got a really good bug report there. But yeah, we'd like to sort out that problem. Basically, the problem is the Kubernetes API client itself doesn't spot that this thing has happened, so you end up with quite long timeouts. Yeah, that's when we'd like to sort out.
Do you know if there's an upstream issue raised around that?
I think there is, and it's kind of it's got blocked on well, maybe a little bit of finger pointing because the Kubernetes client uses the machinery in the Golang standard library for this for managing its connection, and the Golang standard library didn't have a way to time out in this case and to spot it efficiently. So they have a kind of workaround in kubelet, but the workaround isn't in the Kubernetes API itself, if I understand correctly.
So maybe we should be looking at picking up that workaround from the kubelet while they point figure out where the problem is.
You kind of can do what is needed from outside the API, but you sort of have to replicate a bunch of the internal features of the API. So it's kind of the particular settings not exposed. But I think they're working on that. So the Kubernetes community is just waiting for the fix to land in the Go tool chain.
Well, while we're doing shout outs, I noticed that Steve Harris just joined. I wanted to give a little call out to Steve because I've been trying to keep up with him in Slack, but he's been very diligent and persistent in trying to get his canal to Calico
Thanks for
cluster
validating
going.
the effort. I know it's easy enough to just say it's just insane, just give up. But I'm feeling like a bulldog about it.
And what do you know, the guy who wrote the flannel to Calico migration scripts is on the call. Hey, Tom.
Oh, great. We'll see if anybody wants to answer questions about that later.
I'll certainly do my best. Any other issues or shout outs that people wanted to make?
Since he's not on the call, Tomas put one in the list. So shout out to Jesper, Dangaard, Brouer, who's one of the BPF kernel maintainers at Red Hat, and he did a drive-by PR to fix up how we were building our BPF programs. So he came over and reviewed our build process and spotted an improvement you can make there. So yeah, he got the PR for that. Just good of him.
Cool. Well, in that case, I think let's hand over to Yousong, who's gonna show us a little bit about Calico for Windows, which is coming in 3.16.
Cool. So I'm going to share my screen. Is that okay?
Yes, you should. Let me make sure you have permission.
I do. I can share that. Can I see my screen?
Yep.
Yeah, great. So yeah, I'm Song from Tigera. So today I'd like to demo Calico Windows support. This is, as we mentioned earlier, this is a feature we are adding to upcoming 3.16 Calico release. And it basically provides the Kubernetes networking and as well as the network support, policy support for Windows Node. And so today I like to divide it, the demo into 3 steps. The first step is I'm going to show you how we can set up Calico for Windows on Windows node and join this Windows node to the Kubernetes cluster. And so once the node joins cluster, I can then demo some basic connections between Windows pod, Linux pod, and also between pod and service. And after that, I will run a simple policy demo to see how policy can be enforced on Windows pod. And so I have a picture here just to illustrate the setup I'm going to have. Basically, I have 2 Linux nodes, a couple of Linux nodes, and a mass node. And I'm going to spin up 2 client pod on Linux node and 1 server pod, 1 client pod on Windows node. So basically, the whole environment I have is Kubernetes 1.18.6, and the cluster is set up by kubeadm on an AWS cloud environment. And the prerequisite of running Calico for Windows is you need to have Calico running on the Linux side because Calico for Windows require accessing some Calico data stores on Linux side. So today I actually installed Calico 3.15.1 on Linux side, and also I enabled VXLAN mode for Calico. And another requirement for running Calico for Windows is we need to configure the Calico IPAM. That we need to set the strict affinity to true because currently Calico for Windows cannot support kind of borrowing IPs from other IPAM blocks. So yeah, that's the whole setup I have. So I'm going to switch over to my
Song, it's only VXLAN that's supported, isn't it?
Yeah, that's right. Currently only VXLAN is supported, but we are adding BGP support in next release. So at least that's the plan. So this is my Linux console, so I can show you guys my environment. So I have 3 nodes, a Linux node running, and they're running Kubernetes 1.18.6. And I also already created a Windows node that's located in the same subnet of those Linux nodes. So I have already set up the RDP connection to my Windows node. So this is the Windows node. We are going to join this node to the cluster. So the first thing you need to do when you log into a Windows node is you need to copy over your kubeconfig files. This is used by Kubelet to use that config file to connect to the eBPF server. So I have done that. I copied over the kubeconfig file already at the c\k directory. So this is directory normally. We put all the Kubernetes stuff in that directory. Yeah, that's all set. So next step is we need to download installation script where it's actually download Calico for Windows binaries and Kubernetes binaries and setting up everything correctly and eventually join the cluster. Join the node to the cluster. So I have some command here. I believe it's a second. I need to move this over a little bit. Okay. So because it's a preview release, so I just put that into my personal account. So if I run this command, basically it's just download. Let me see. It's a bit slow. Okay, sorry. Yeah, you can see this install Calico PS1. This is PowerShell script to install Calico for Windows. It's downloaded at this location. So the next step, we would just run this PowerShell script, but we need to provide the Kubernetes version, which should match the Kubernetes version on the Linux side. So I'm going to. Okay, so the first thing it does is actually downloading a couple of helper scripts and is also downloading the Windows Nano Server Docker image. Basically, we would need this Docker image to acting as the pause container image for Windows pod. So it's doing that. Yeah, it's tags the image to pause latest. Next is to download some utilities that to unzip the Kubernetes binaries we're downloading. Yeah, this is Kubernetes binary we're downloading. And then we're downloading Calico for Windows release. And unzip Calico release, yeah.
Is the first part of that basically the standard scripts that Microsoft had released?
No. What do you mean first part of release? First part of scripts, which part?
Right, the first part, it looked like it was grabbing some scripts from the Microsoft SDN repo and running those. Is that how we install Kubernetes here?
Those scripts are provided by Microsoft for some kind of utility functions. Things like create networking, deleting networking, and checking the networking status, things like that. So there are different scripts of how you download Kubernetes binaries and install Kubernetes service. So currently we provide an example script for you to do that. So, okay, so it seems Calico for Windows is downloaded and it's starting Calico service. So we are running Calico as a service because currently Windows does not support running host networked pod. So yeah, we lost connection. It's because during the setup, Calico has to create the vSwitch. So set up some internal networking stuff. So during this period, your connection may be lost for like a second or two. So okay, we all going back now. So you can see the two Calico services are running. Calico Felix, which is similar to the Calico node service, Calico node running on each of Linux nodes. We are running Calico Felix service on Windows node. And also we are running Calico node startup service. And yeah, so we also need to kind of open up a firewall rule for VXLAN port 10 to 50 that it's allow the kubelet to access the Windows part. So we can do kube exec. Yeah, it seems all done. So what we need to do is we need to install and start kubelet and kubeproxy service on this node. So I can, if I check, the Calico for Windows has been installed as this directory, Calico Windows. Yeah, there's a couple of kind of subdirectories there, include logs, nodes, and libraries. And the one we interested is Kubernetes, where we provide a couple of example PowerShell script to install and run Kubernetes services. So if I can just install kube service. So it's install kubelet and kubeproxy as a Windows service. And I can then start service. Start service kubelet. Service should be started and start service. Yeah. So to verify, we can use get service kubelet. Sorry. So these are two Kubernetes service, and we can also do the same for Calico service. Felix running, Calico node service is running. Yeah, we all set. Okay, so if I go back to my Linux console, and I'm doing the same thing here again. A Windows node has joined the cluster, right? So I think we have successfully set up the Calico for Windows on Windows node and also started Kubernetes services. And so this Windows node joined the cluster. If I check, I have already created couple of Linux part and service and client part at the, I have the demo namespace. Oops, sorry, that's wrong name. And also I got a couple of part created already. So you can see I have client A, client B, and a network Nginx server pod running. And I also had, see, a service created with which is backed by the Nginx pod. Yeah, it's all set. So what I need to do next is I'm going to create PowerShell Windows part. So it will going to run on Windows node. So I have a YAML file ready. So it basically it's just running a server core and it just sleep there. So what I can do a PowerShell. So this is acting as a client, a Windows client pod. And next, I'm going to create a server pod on Windows node. So I use a porter image, which is a simple HTTP server on Windows node. So this, if I all created, all the pod created, so I just, okay. It's because those image already being pre-downloaded, so it's pretty quick now. But if you run in production or create a new Windows, it could take a while for Windows part to be ready. So it seems we have an Nginx server running on Linux node. We have 2 client pod running on Linux node. We have a PowerShell Windows client running on Windows node, and also, oh, sorry, this one, and also a porter server pod running on Windows node. So next, we can check some connections. So first of all, what I can do is I can run this command. Basically, it's just getting, oh yeah, I need to check. I also created the Windows service as well. So you can see a portal service has been created. So we can run this command that it would allow client A to access a Windows service. If I run this, yeah, it got a good return, good results. So I can do the same for from my another client. Yeah, so it's fine. And next step I want to show you is we can, oh, maybe this. We can go into the Windows client. This is the Windows client. So what I can do is I can try to access the Nginx service from Windows client. Request the Nginx service. So we can do a full name, Nginx demo. Yeah, same connections there. So Windows client has successfully connected to the Linux service. It's all good. And so the connection is good. So what I will do next is to apply network policy on Windows server pod. So basically I have a policy YAML here. You can see this is called allow client A. Basically it's actually applied on the Windows pod porter server pod, and it's ingress policy. And basically it says allow any pod which have this label client A to access the Windows porter service. So I can apply policy. Yeah, policy has been applied. So if I do the same access, like I'm running and I try to access the Windows service from client B, it should go ahead, it should go through because, no, sorry, it shouldn't go through because there's no allow rule for client B. Yeah, it's being blocked. But if I change that to client A, the traffic still should go through, right? And if I delete this policy, the client A and client B both should be able to access to the Windows service. Yep. Cool. That's all I have.
Very cool, Song. Thank you for that awesome demo. Does
Thanks, Song.
does anyone have any questions for Song? If not, then we can move on to just general Q&A or any other discussion that folks have. Steve, I know you
I have
some
many questions. I'm just not sure if it's the right forum for them. I've just noticed in my recent trials with getting Calico running that there are some things that it does for you, from what I understand, when you first install it. I've taken those for granted for years. I've been using Calico for several years, though you never know it from what you've been seeing. But trying to layer it into a cluster where there's already a CNI installation there, I've struggled with trying to make sure that those things that it would normally do initially happen. You know, the example is configuring the default IP pool, let's say, to use IP and IP encapsulation cross subnet, turn on the outgoing NAT, that stuff. And I don't understand which components take care of setting that stuff up, because we now have the pods like the Calico Kube controllers, and we've got several Typha pods. We've got lots of Calico node pods. Is there a document, or can somebody explain the basic responsibility breakdown of those pods?
I'm not sure that there is a document. I'm just trying to think if we have that sort of content right now. But yeah, so as far as kind of split of responsibility there, the stuff that like specifically you're talking about around creation of the initial IP pool on first install is done as part of Calico node bootstrapping. So there's some code that gets run every time Calico node starts up that checks if IP pools exist, and if they don't, it tries to create one with whatever parameters you've given it. So if you look in the Calico node daemon set, that's where you can see this. There's like a bunch of IPv4 underscore something environment variables that it respects there. So that's the relevant piece for that. Kube controllers is it has a collection of different controllers in it. It's mostly there for well, it depends a little bit if you're using etcd directly or going through the Kubernetes API, but it's mostly there for things like garbage collection of older resources that aren't relevant anymore, and sort of non-critical path operations like that. And then Typha is in the data path from the Kubernetes API server to Calico node as a means of kind of amplifying the scale of the Kubernetes API server.
Okay, so that means that if several Calico node pods were to start up racing one another and by chance be configured differently, the end result would be like a last one wins. Is that correct?
It should be the first one wins. So,
yeah, okay.
Or well, for IP pools, I'm not actually sure. That's
You really don't want to be starting multiple Calico nodes with different config on the same cluster. You'd have to go to quite some lengths to do that. So I would just stop doing that and use daemon set.
I think in Steve's case, he's got two daemon sets. He's got a canal one and a Calico one that he's switching to.
Yeah.
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 And
It's a little hard to tell what the consequences are of, say, deleting the canal daemon set before installing Calico. In other words, you've got nodes running. Presumably, the deleting the daemon set will delete the pods on each of those nodes. I really don't know whether or not Calico node is doing anything actively. I understand it runs bird when you're using BGP. But in other words, if you drop a Calico node pod from an existing node and then put a new one in its place, say seconds later, would that work, or was that doomed to fail?
So that kind of thing should work. So it's not a good idea to run two Calico node pod variants at the same time, because they will fight each other. So the component, one of the components in there is Felix, which is our per host agent. So that's the component that actually writes the policy rules into the data plane and makes sure the routing kit stays in sync and various other things. And that's expected to be a single instance per node. So it will fight each other if you have more than one instance of that on the same node. Transiently running two for a few seconds, like they'll fight backwards and forwards, and then one of them goes away, and the other one will like sort everything out and reset everything. But better to remove one and then add the other, which is what normally happens when you do a rolling upgrade from one version of Calico to another. I'm not sure about Canal if it has the right label set up so that it will prevent prevent Calico node from running as well. I'm not sure.
Yeah, I think in my experience, it does not. At least I think. I might be misinterpreting what I saw, but thanks. That helped me understand what's going on better.
Hello, everyone. I also have a question, maybe a short one. That could you please answer that what is the reason, maybe the technical reason, that only Felix is using Typha component? In a high perspective view, other components also can have some benefit of using it.
So in recent versions, we do use Typha in more cases. So each Calico node pod has more than one daemon running inside. Felix is one, Confd is another, and in recent versions of Calico, Confd and Felix both connect to Typha to get the offload benefit. And I think Casey recently added a third thing that.
it wasn't me, but I know the one that you're talking about. The tunnel IP allocator also is driven off of Typha.
So we are going through Typha there now. It's Typha is not like super generic. It basically offloads like one of the backends for a particular component. So we have to do a little bit of work for each component that wants to listen through Typha, and it's also Typha is based on our internal API rather than say the Kubernetes API. So it's not a generic like fan out proxy for the Kubernetes API, internally it converts everything to the Calico internal model, and then it forwards on messages to Felix and Confi and the new IP allocator.
Thank you. It makes sense.
I have another one. And sorry if you addressed this earlier before I was able to join. With the coming eBPF, BPF data plane stuff, are you going to follow the model like Cilium and provide the option to get rid of kube proxy?
So that's actually an integral part of what we do in the BPF data plane. So the way we've structured our BPF programs means that we basically have to take on the kube proxy responsibility. But it's one of the areas where we've managed to improve quite a lot over what you get from the sort of data planes people are using at the moment. So our load balancing preserves the source IP, for example, and we have lower latency than the load balancing done by kube proxy. So a couple of nice improvements, but you do actually have to replace kube proxy to use our BPF data plane.
I recall that when Cilium was first coming around, I didn't follow when this changed, but they could get rid of kube proxy for all but node ports. I guess that was their one thing. That was a sticking point for a while. I think they since figured that out. But do you know, was that a special challenge for you as well?
Yeah, so we had to do work to handle node ports. One of the things that we do is we put programs on the like your ETH0 interface, whatever that's called on your platform. And we do that so we can catch the packet as soon as it arrives at the host. And at that point, we can inspect it to see if it's going to a node port or what have you, and forward it on appropriately. Or if we detect that it's going to a local pod, we can use like BPF redirect, which is one of the APIs there, to send it directly to the pod and kind of skipping everything that would normally happen to that packet. And that gives us a performance boost. One of the reasons we structured it that way is because Calico IP tables mode has host protection policy as well. So we can write rules that protect the host. Now, we don't support that in the BPF data plane yet, but in order to support that in future, we need to have a program on your ETH0 interface, and we need to structure the programs in that way, so we can catch the packets nice and early and be in a position to police traffic to the host as well.
I see. Thank you.
Just got a few minutes left. Are there any other questions? If not, then we can end 8 minutes early, and I can go grab some breakfast.
Sounds good. Thank you.
Thanks for coming, everybody. See you.
Bye, everybody.
Thanks, everyone.
In a month.